All right, here we go. Radical conjugate theorem. Radical conjugate theorem. It's a theorem, right? It's a theorem. It's in a box. Very important. It even has its name. It's called the radical conjugate theorem. Sometimes it's called the irrational conjugate theorem. Let's go ahead and write that up here too. Sometimes it's called the irrational conjugate theorem. Okay. Here's what it says. If you have a polynomial function that has rational coefficients, that means that the numbers in front of the x's are either fractions or whole numbers, right? Rational coefficients. Then if x plus the square root of b is the root, or 0, of that function, then a minus the square root of b is also. Okay? That's built right into the quadratic formula. Whenever you have ax squared plus bx plus c, you know when you set it equal to 0, you get x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. The quadratic formula has the radical conjugate theorem built right into it. See that? Negative b plus the square root and negative b minus the square root. There's two roots there, right? See that? There's two roots, and they're conjugates of each other. One's plus, one's minus. All right, let's go ahead and try out our new skill. How is that going to be useful to us? Using synthetic division, find all the real roots of x to the fourth plus 3x cubed minus 9x squared minus 15x plus 20. Given that the square root of 5 is the root. Okay, given that the square root of 5 is the root. Well, being a fourth degree polynomial, I would like to know how many roots to get it down to a quadratic. 2. Okay, so they're giving me square root of 5 as the root. But because this is a polynomial and all my coefficients are integers, do I know another root as well automatically without them even telling me? Yeah, good. Negative square root of 5. Because the theorem says if x equals the square root of 5 is a root, comma, then x equals negative square root of 5 is 2. That's what the theorem tells us. So I don't have to give you both of those roots, do I? I only have to give you one, and I can give you either one of them, and you would have to know then that the other one is a root also as well, additionally too.
So when it says x equals the square root of 5, it's always implying plus or minus?
Yes, that's what that means. If I tell you minus, it means plus or minus. If I tell you plus, it means plus or minus. You can't have one without the other, like love and marriage. Love and marriage, go together like a horse and carriage. Okay, horse, just like a horse and carriage. Okay, you can't have one without the other. Okay, let's go ahead and write our coefficients down. 1x to the fourth, 3x cubed, negative 9x squared, negative 15x, and 20. All right, now we're going to draw our synthetic division line. We're going to put our root box in the front, and we're going to put our remainder box in the back. And I know I'm going to get 0 there. Let's go ahead and do the positive square root of 5 first. Now, we are going to have a little bit of space over here on the workbench. You'll see why. Watch this. We're synthetically dividing for the first time with an irrational number. You see that? Up to now, it's been a rational number. Bring down the 1. The process is the same. Multiply, and you get the square root of 5. You slide it up, and now you have to add. What's 3 plus the square root of 5? It's 3 plus the square root of 5. OMG, I now have a binomial. Now I have to multiply. If I'm multiplying, it looks like this. It's the square root of 5 times 3 plus the square root of 5. You don't need to come up to the side for this if you can distribute in your head. You think you can distribute in your head? 3 square root of 5 plus, what's square root of 5 times square root of 5? Square root of 25, also known as 5. Yeah, there's a little theorem that says the square root of a squared is a. Okay? So, if I distribute in my head, I get 3 square root of 5 plus 5. And I slide that up there. And now I add vertically. But I can only add like terms, correct? So it's 3 square root of 5. And what's negative 9 plus 5? Negative 4. That's combining like terms. Combining like terms. Now, I distribute again. 3 square root of 5 times square root of 5 should be what?
5.
It's 5 times 3. There's a 3 there, right?
3.
Yeah, so the square root of 5 times the square root of 5 is 5, times the 3 gives us 15, and then minus 4 square root of 5. Everyone okay with that? If you need to do it off to the side, that's where we do it. The square root of 5 times the square root of 5 is minus 4. If I multiply here, I get 3 times 5 minus 4 square root of 5. And of course, what's 3 times 5? 15. So you should be able to do that in your head. And now I add vertically, and what happens to my 15s? They subtract out, they cancel, and I'm just left with negative 4 square root of 5. Now, what's the square root of 5 times square root of 5? 5. And what's 5 times the negative 4? Orale. Orale. It worked. Well, you didn't like it because it was the first time you saw it, right? Same thing when you first tried broccoli, and now look at you. You still don't like broccoli. Okay. That was a long shot. I was trying. Yeah. I thought maybe since both your names started with B, you were a broccoli fan now. Brady loves broccoli. Brady. That makes a good t-shirt. All right. Now we should synthetically divide with what? Negative. Yeah. You should always synthetically divide with your conjugates back to back. Okay? Back to back. If you don't synthetically divide with your conjugates back to back, it's going to get messy. In other words, like if I happen to know another root already, like let's say 1 worked, I wouldn't want to do a 1 right now. You always want to do your conjugate roots back to back. Why, you ask? Well, I think you'll see why when we do it with the square root of negative 5 or negative square root of 5. Bring down the 1 and multiply, and you get negative square root of 5. What happens to your radicals now that you have done the conjugate back to back? What happens here with the square root of 5s? They subtract out, and you're just left with 3. Oh my gosh. What's 3 times the negative square root of 5? Negative 3 square root of 5. What happens with your radicals? They cancel, leaving you at negative 4. And if you multiply, you get positive 4 square root of 5. What happens to your radicals? They cancel. If you do your conjugates back to back, your radicals should cancel on that next iteration. Okay? It's kind of a checkpoint right there. Now we have a quadratic, don't we? This right here means we have x squared plus 3x minus 4. We can set it equal to 0 now, and we're home free. You want to use the quadratic formula, or should we try to F it first? Let's F it first. We'll try. We don't know if it's going to work. Okay? X and x, factors of negative 4 that add up to 3? 4 and 1, and which one's positive? The 4, yeah. So we get x equals, excuse me, negative 4 and positive 1, and our conjugate pair that we already synthetically divided out, plus or minus the square root of 5. Yeah. And there you go. These are your roots right here. Done.
So with the plus or minus square root of 5, would that be a multiplicity of 2, or those 2 different?
No, they're 2 different roots, and they're both multiplicity 1. In fact, I have 4 distinct roots for a 4th degree polynomial. They're all M1. So if you were going to sketch this, you would have 1 right here. You'd have 1, 2, 3, 4 over here, negative 4. The square root of 5 is negative 2 point something, so there's the negative square root of 5. And then you got 2 point something right here, the positive square root of 5. All right. What does this one open up or down? It's an even degree, so we could say open if we want. It opens up. That's an easy way to get both them behaviors being positive. So it would come in like this, da ti da 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 da, something like that. Again, I'm just guessing on what the local max and mins are. Correct? We don't have a calculator, or we don't care about the calculator, and we don't have calculus. So that's not the point of what this lesson is. That's another lesson. Okay, cool. Kind of fun, right? Like a horse and carriage, like love and marriage, like peas and carrots. Can't have one without the other. Yeah, maybe. Right. I guess you can't have peas without carrots. If you have the square root of 5, you automatically get the negative square root of 5. Yeah, yeah? Yeah, yeah. All right. Okay. Reduced factored form. We already talked about this. Reduced factored form is when you have it into linear factors of the form mx plus b. Mx plus b. Ah, stupid highlighter. There it is again. Mx plus b. Those are irreducible linear factors. Or you could have x squared minus a. I'm going to call it x squared plus a. I'm actually going to call it x squared plus a, where a is a positive number. Okay? So here's some irreducible factors.
Because you can reduce x squared minus a, right?
Yeah, yeah. If A is positive. If A is negative, that's why I put x squared minus A. A can be negative and then it turns into plus. But if I put x squared plus A where A is positive, it looks better. So irreducible factors are like 3x plus 1, x minus 5. 2 would be an irreducible factor. It's a constant. And x squared plus 4. Okay, x squared plus 4 does not work. However, x squared minus 4 factors into x minus 2, x plus 2. So you can't factor the sum of two squares. Sum of two squares is not factorable. So to get it into reduced factored form, or it's the same thing as its prime factorization, if you want to think of that, prime factorization of polynomials. Write an equation in reduced factored form of a polynomial of lowest degree with the following properties. Okay, f of negative 1 equals f of negative square root of 2 equals f of 2 plus the square root of 3 equals 0. Oh, and f of 0 equals 5. Okay, well, whenever you are given f of negative 1 equals 0, f of negative square root of 2 equals 0, f of 2 plus square root of 3 equals 0, what does that tell us about these three guys right here? They're roots, right? They're roots. Now, let's go ahead and list all the roots here. I know that negative 1 is a root. I know that negative square root of 2 is a root. But if negative square root of 2 is a root, what automatically comes attached to it at the hip? Like a horse with a carriage. Yeah, a positive square root of 2. That has to be there. Okay? And I know that 2 plus the square root of 3 is a root. But because it's an irreducible radical, what must also be a root? 2 minus the square root of 3. Yeah. So those two conjugates that were not listed, they have to be there implicitly. I don't have to tell you about them. They are automatically going along for the ride. Now, if we want it to be a polynomial of lowest degree, this is the fewest number of roots we can have, right? The fewest number of roots. So what would be our degree? If they're all M1s? 1, 2, 3, 4, 5. We're going to have a fifth degree polynomial. All right, now what we're going to do is very similar to what we did in the warm-up. We're going to write our general equation. Our general equation, we get f of x equals a times, and it's just going to be x minus each of the roots, right? So here we go. It's x minus negative 1. What's x minus negative 1? X plus 1. Okay. And the next one is x minus negative 2. What's x minus negative 2? X plus the square root of 2. Sorry, yeah, square root of 2. And then the next one would be x minus the square root of 2. We got that. Now be careful here. I have x minus parentheses 2 plus the square root of 3. We got two terms now on the root. So I'm going to put parentheses, and then it's x minus parentheses 2 minus the square root of 3.
Or would it be x plus, or no?
No, they're always x minus. It's always x minus. It's always x minus. Where does the sign change? The sign changes right there. 2 plus and 2 minus. Now, let's go ahead and find the value of A. You want to find the value of A? Yeah. Well, let's do one thing first. Here's what I'm going to have you do. I want you to do this right here. I want you to expand. If you ever have radical factors, you want to expand your radical factors. It puts it in a user-friendly format, okay? A user-friendly format. Expand. Look, this one says quadratic factors with no radicals. No radicals, okay? I should have emphasized that before we started. But now's a good time to do it. You also don't want imaginary units visible. We don't have that yet. That's going to be in 3.4. But right now, in our factored form, we don't want any radicals visible. So let's go ahead and expand this out. If I work straight down, let's do this off to the side for, well, let's do it in the flow of the problem. I think we can handle this. What is x plus the square root of 2 times x minus the square root of 2? Those are conjugates of each other, right? And when you multiply conjugates, the middle terms cancel. Yes, yes? So I should be left with x squared, and then the inner and outer cancel. I'm not even going to worry about it. It's going to be plus radical 2x minus radical 2x. Those cancel. And I'm left with minus, what's the square root of 2 times the square root of 2? 2, okay? So that simplifies to that. Now that's still factors. X squared minus 2 still factors, but notice It's a more user-friendly factor, okay? It's a more user-friendly factor. So it's not necessarily the prime factorization. I forgot what I meant here by reduced factored form. Reduced factored form is not necessarily the prime factorization. It's the pretty factorization, if you want to think about it. The pretty, quote unquote, pretty in the eye of the beholder. It's the pretty factorization. It's the one that doesn't have any radicals in it and the one with no imaginary units. That's why in Algebra 2, you weren't taught that x squared minus 2 is the difference of squares, because 2 is not a perfect square. It is a difference of squares. It's just... Whoa!
Sorry.
Everyone get under your desk if you can fit.
That's. It does say there's a tornado. Why'd that do that?
That's cool. No, I'm glad. If there's a tornado coming by, we're going to stop doing math. Just FYI. If there's a tornado that comes by the window outside,
We gotta watch.
we're
gonna stop.
we're going to stop.
That's on silent.
Well, actually, how about this? I'll just pause instead of stop. Okay, yeah. Now, here, this is going to be a little bit more challenging because I have a binomial factor. So, if you want to try to do it in the flow, let's do it. X times x is x squared. What's going to happen to the inner and outer factors? They're going to cancel, and we're going to be left with minus parentheses. What's 2 plus the square root of 3 times 2 minus the square root of 3?
4 times 3. Right?
We're just expanding these two factors right here, Wyatt. X plus square root of 2 times x minus the square root of 2. Actually, I don't think I want to do it like this. I can already tell that we're losing some people. So let's go off to the side. Let's go off to the side and focus on these. These are the factors that are going to require a little bit of extra work. I would say step one, to make it easy on yourself, let's go ahead and distribute the negative. So off to the side here on my workbench, because there's a binomial root, okay? Why are we doing this off to the side? Why did we not do that off to the side for x squared minus 2? Because it was just easy. But now we have a binomial root. So let's distribute. We get x minus 2 minus the square root of 3 and x minus 2 plus the square root of 3. It's like one of the national, it's a national alert system. It's supposed to,
Oh, is it?
yeah, even when your phone's on silent. Yeah, maybe, well, I don't know, but your sound went off. I'm glad it did. That was kind of cool. I almost feel like I need to quit teaching and go out there with my cape and kind of blow the tornado away.
This small brief tornado caught on camera downtown.
Do you see what we did? We distributed the negative. Everyone okay with distributing the negative? That gets rid of the parentheses. Are you okay with that? Okay. Now what we're going to do, we can't FOIL over here because FOIL doesn't work because we have a 3 by 3. So what we're going to do is we're just going to expand. We're going to distribute the x all the way through. We get x squared minus 2x plus square root of 3 times x. And then we do it for the negative 2. We just distribute the negative 2 all the way through, and we get negative 2x plus 4 minus 2 square root of 3. And then we do it for the final. We distribute the negative square root of 3, and we get negative square root of 3x plus 2 square root of 3, and then we get minus 3. This is why we call it reduced factored form. It's the pretty version. Now let's combine like terms. I have an x squared, so there's only one of those. Let's look at my x terms. Do I have any x terms? I have a minus 2x and a minus 2x and a minus square root of 3x. And oh, these cancel, don't they? The plus square root of 3 and the minus, the radicals should cancel. So I get minus 4x, and then what's left? I get a negative 2 square root of 3 and a positive 2 square root of 3. Those radicals canceled, and I'm just left with 4 minus 3, which is what?
How does the negative 2x and the positive or negative 2x cancel? Oh wait,
They didn't. They became negative 4x.
what was the ones that canceled?
All the ones with the radicals should cancel.
Oh, okay.
All of if you expand it right, all of your radicals should cancel. Okay?
Got it.
That's why if I asked you to factor x squared minus 4x plus 1, you wouldn't be able to do it. You have never learned a way to factor it when there's no integer factors of 1 that add up to negative 4. But it does factor. It factors into what we started with right there. It's just not very easy to undo. But going forward, it's a little bit easier, right? It's just a sledgehammer method. We just distribute everything out and we combine like terms. That's what I'm going to bring back into my project over here. That's x squared minus 4x plus 1. All right, so here's your general equation in reduced factored form. Your general equation in reduced factored form. You want to get it in reduced factored form before you find the value of a, because it makes it a lot easier, okay? Now let's find a. We're going to say at the point 0, 5, at 0, 5, we'll plug in a 5 for f of x and a 0 for x. So we get a times 0 plus 1 is 1, 0 minus 2 is negative 2, and 0 minus 0 plus 1 is 1. You see how easy it is to plug in a 0 when it's in reduced factored form, as opposed to the prime factorization. That's what this is right here. This is really its prime factorization. But the prime factorization can be a little bit ugly. So the pretty reduced factored form doesn't have any radicals in its factorization. All right, now we solve and we get 5 equals, that gives us 2a. So a equals 2/5. Negative 2a, thank you. So that's negative 2/5. Good catch. Sorry, it's hard to concentrate when you know there's a tornado on the way. I think my eraser's too big.
I don't remember the last time we had it. It was like third grade.
Well, it says it's the same market.
All right, so we need the transitional word, right? So, or therefore, or consequently, now we rewrite it as f of x equals negative 2/5 times x plus 1 times x squared minus 2 times x squared minus 4x plus 1. And there it is. That's the particular solution in reduced factored form. Not the prime factorization, but in reduced factored form. The pretty version. Now, we could expand that completely out if you want, but that's just going to be an exercise in swinging a sledgehammer. More distributing, okay? So, when I give you radical roots, x minus each of those roots is going to be a factor. You have to expand out the conjugate pairs to get it into a pretty factor, okay? So, let's come back up here again. Expand your radical. I should, instead of saying radical factors, I should say your radical conjugate factors. Okay, you want to go off to the side if you need to for either one of them. Hopefully you could do the x plus root 2, x minus 2 in your head, but the one that has the binomial roots, you need to go off to the side and do that. Okay, bring it back into the problem. All right, so there you go. Looks pretty good, huh? All right, any comments or questions on that? All right, let's move on to example 12. Kind of shifting gears here a little bit. It's a little different type of question. Find the remainder when 6x to the 1000th power minus 17x to the 562th power plus 12x plus 26 is divided by x plus 1.
Wait, to fill in the.
I don't know, right? You're thinking that, right? If I divide by x plus 1, I can also synthetically divide with what? Yeah, I can good. Way to go, Rhino. I can synthetically divide with x equals negative 1. Now, when I do synthetic division, as it was already pointed out, I need placeholders. So I have 6x to the 1000th. I would have 0x to the 999th, 0x to the 998th, 0x to the 997th,
So
all the way down to negative 17. Wow, I would need a lot of zeros there, wouldn't I?
So is this saying that this degree is 1,563?
No, the degree is 1000. It's an expand. This is in standard form. So we don't add up the exponents.
Even degree.
In standard form, you don't add up the exponents. You only add up the exponents in factored form, recall. But this is a 1000th degree polynomial. I would need a lot of placeholders, wouldn't I?
Long.
Yeah. So you can either do long division or you can use this little theorem up here. The division algorithm. Remember, dividing by x minus a is the same as evaluating the function at a. And the value that you get is the remainder. If the remainder is 0, it's a factor. Dividing by x minus a is the same as evaluating the function at a. So let's come back over here.
So
I can say dividing.
1 equals 0.
Yeah, there's a better way to do it. Instead of synthetically dividing with x equals 1, I can just say this right here. Dividing, we'll spell it out, dividing by x plus 1 is the same as f of negative 1. Okay, so there's no reason that we need to use synthetic substitution here or synthetic division. Sometimes that's nicer, but in this case, isn't it easier just to plug in? Like if I let this function equal f of x, I can say what is f of negative 1? And I can just use direct substitution. Direct substitution, not synthetic substitution. What would negative 1 to the 1,000th power be? Negative 1?
Alright, yeah, 1.
Why are you doing it again?
Maybe there's another tornado.
I don't know.
Or maybe it didn't get our attention the first time.
Okay, stop.
I think that's an app. I think it's like spam, pre-cal spam app.
I have an app, but
No, everybody, what is negative 1 to any even power, including 1,000?
1.
It's positive 1, right? So that's 6 times positive 1. Minus 17. What is negative 1 to the 562th power?
1.
It's also 1 because it's an even number, right? And then I get minus 12 plus 26. Isn't that a lot easier than synthetic substitution where I need placeholders? Yes. Okay, now we just evaluate it. That's 6 minus 17 minus 12 plus 26, which is going to be from left to right. That's negative 11. And then I get plus 14, which gives us what?
3.
3. Now, my question to you is this. Is x plus 1 a factor of f of x? No. Why not?
Because the remainder is 3.
The remainder, good. The remainder is 3. The point is negative 1, 3. There's a point on the graph of f of x called negative 1, 3, which is not an x-intercept. See how it's all related? The function value at a is the remainder when you divide by x minus a, and vice versa. The remainder when you divide by x minus a is the function value at a. So synthetic division, as nice as it is it always the answer? No. When I was growing up, we actually had tornado drills, just like we have evacuation drills now.
We did too. And then we went
Oh, did you? And you'd crawl under your desk?
we would have to go in the hallway.
Oh, you sit in the hallway with your, yeah, where there's no windows with your arms over your, yeah. Okay.
Everybody's
Well, just listen carefully. If you hear like the sound of like a 747 outside the window, that is not a runway. So that means that there's probably something else coming down the pike.
I don't think I've ever seen it.
You want to Google one? I'll show you what one looks like.
You should look up they said they got a video of it in San Antonio.
Tornado. A tornado kind of looks like a tornado. I put a tornado. A tornado, Brady, kind of looks like a funnel cloud. I know you said you've never seen one,
Yeah.
but it looks kind of like a funnel cloud.
I've seen the movies.
Oh, so you have seen a tornado?
Tornado.
Western Australia.
There's a tornado. You mean you've never seen a tornado live?
Yeah.
Okay. I misunderstood. I thought you'd never even seen a tornado.
No, I've seen pictures like that.
You've seen cows flying by.
Yeah.
In the movie.
Tornado.
Sharknado. Sharknado 2 is better than Sharknado 1. That's just a hot take.
That's historical accuracy.
Yeah. All right. Now, when division is done, the remainder is not 0, then the divisor is not a factor of the dividend. We can still do the division, though. I've already shown you this, right? The polynomial divided by the divisor is the quotient plus the remainder over the divisor. I already showed you that, okay? Let's do it on example 13. Example 13a. Divide 13 by 4. Okay, 13 divided by 4. Well, let's go off to the side here and do long division. 4 goes into 13 how many times without going over? 3. What's the remainder? 1. So that means we can write it as 3 plus 1 over 4. Yes, yes? 3 plus 1 over 4. And of course, we stylized that in little school as 3 and 1/4, as the mixed number, 3 and 1/4. Now, notice what else we could do. If we bring this down here, I can also write it a slightly different way. If I simply multiply both sides by 4,
With 12.
I get the 4s dividing. I get 13 is the same as 3 times 4 plus 1. That's really kind of the same sentence, isn't it? 13 is 3 times 4 plus the remainder 1. Yes, yes?
Yeah.
Which is the says, whoa, now we're getting a news flash.
I don't know what's going on with my phone today. I can't turn it off.
These two sentences say the exact same thing.
Stop.
13 divided by 4 goes in 3 full times with 1 out of 4 left over, or the number 13 is 3 times 4 plus the remainder of 1. Okay? Let's do the same thing now with this right here. 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. I'm going to divide it by x plus 2. Let's divide it by x plus 2. Now, to divide it by x plus 2, do you want to use long division or synthetic division? Synthetic. Let's use synthetic. 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x. Does that come next? No, I need to have a 0. Very good. There's no x squared term, so I got to have a 0. And then I have a 7x and then a 3. So watch those placeholders. And having a placeholder of 1 here was better than having like 1,000 placeholders. All right, so I draw my horizontal line, and I put a -2 here. Can I go ahead and put a 0 in my remainder box at the end? Do I know if it's going to be a factor? No, I'm testing to see if it is a factor, essentially. All right, bring down the 3. You multiply, you get -6, -1, 2, -2, 4, 4, -8, -1, 2, 5. Synthetic division is a lot faster for substitution now than direct substitution. Would you agree? If I had to use direct substitution, I would still be on -2 to the 5th. -32, and then -32 times 3 is -64. I'd have to write that number down and then move on to the next term. But doing it synthetically, substituting it, it's easy, right? So is x plus 2, let's call this f of x just so we can refer to it as f. I can now say that this is the same as f of -2. Is x plus 2 a factor of f? No, because the remainder is what? 5. But, bless you, we can say this. We can say that 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3, when I divide it by x plus 2, it does equal what? Well, what is the degree of the depressed polynomial right here?
3x squared, 3x to the 4th.
Yeah, if this was a 5th, if this is x to the 5th, this is x to the 4th. So, as you said, it's 3x to the 4th
Plus, or minus 1x to the 3rd.
minus 1x to the 3rd
Minus 2x squared.
minus 2x squared
Plus 4x minus 1.
plus 4x minus 1
Plus
plus
5 over x minus 2.
not x minus 2, x.
Plus 2.
There you go. All right, that's analogous to this right here. These two are analogous now to each other. The division, it wasn't a perfect factor, so I can say it's the quotient, which is the fourth degree polynomial now instead of just the number 3, plus any remainder, which for us was 5, out of the original divisor. Now, if I multiply both sides by x plus 2, I can change the sentence structure a little bit, get the exact same meaning, but let's multiply both sides by x plus 2. It's going to divide out on the left, and I can have 3x to the 5th plus 5x to the 4th minus 4x cubed plus 7x plus 3. That polynomial by itself is going to equal the 3x to the 4th quotient minus x cubed minus 2x squared plus 4x minus 1 times the x plus 2. And now it's just plus the remainder. That lines up with this type of sentence. I just multiplied both sides by x plus 2.
Really? Oh, because that, okay.
Yeah. The top one in green is basically saying 13 divided by 4 goes in 3 full times plus 1 left over out of 4. The bottom line says 13, the number, is 3 times 4 plus the remainder of 1. Okay?
So which way would you prefer?
They both mean the exact same thing. I might ask for it. This method here, this one here is probably the one I'd ask for. This is your polynomial divided by your divisor. What did I say right here? Yeah, is your quotient plus your remainder over your original divisor. I like that one.
Got it.
Yeah, but we could just, it's just algebra from there to there, right? From green to red, it's just algebra. You just multiply both sides by the quantity x plus 2 and distribute. Isn't 13 3 times 4 plus 1?
Yeah.
Yeah. It's the product of the quotient and the original divisor 4 plus whatever any remainder is left. Okay? So it's just 2 different ways of writing the same thing. They both mean the exact same thing. The sentence structure is just a little bit different. All right. How are we doing on time? 4 more minutes. Ba-da-ba, ba-da,
We should finish it
ba-da-ba, ba-da-ba. I kind of agree with you there.
Notes to Monday.
Yeah, we'll finish tomorrow, and then your worksheet will be due on Monday, and we'll quiz on. Well, no, we won't quiz on Monday. We're actually gonna skip the next section, which is a real short section, and we're gonna jump to 3.4 on Monday. So no quiz on Monday. The reason no quiz on Monday is I'm getting observed in second period, and then she needs the whole period to observe, so no quiz. But we will quiz on Tuesday, next Tuesday. Okay. But worksheet is due Monday for sure. All right, we're done. We'll be done.
Hopefully nothing-
Okay, keep your head down. Stay ducked in case of a tornado.